So, as always, the code for this question will be in the description, but if you want the explanation, you can continue watching this video. The thing is, this question is, it has bothered me for this entire day, from morning 6 o'clock till afternoon 12:50. This question was the only thing that irritated me in my mind. Once I found solution, it was so easy. Okay, it's just that you have to think a certain way. But let's not rush ourselves. Let's look at the code. Not the code, the question. They'll give us a bunch of sets. In this case, you have 1, 2, 3 as a set, 4, 5 as a set, and 3, 4 as a set. What they basically asked us is, okay, you need a set which can take a union of any of these, or all of these, or none of these, such that, and multiple of these two, such that the resulting set you have should not be equals to the union of all these. Get my point? Which basically means that, as I told you before, the union of all of these, it's not possible actually. You can take a union of none of these, any of these, to get a set which is not equals to the union of all of these. Now you can say, okay, I can take any of these. No. The number of elements in the union you take should be maximum. So in this case, you could have taken any of the union, but you need to take a specific union, any of them, and maximum with maximum elements. Now in this case, what will happen is you don't have to actually return the union. You just have to return how many elements will that maximum set, that hypothetical set that you have constructed from these, which will have, it's not equal to the union of all of these, but with maximum values. What will be the maximum values of that set? This is basically what they asked. You have to take the union such that it will be maximum and return the maximum values of the resulting set you have. Okay. Now that's clear out of the way. The first thing is, how do we get this thing? How do we get to a conclusion where, okay, once if you add this thing, if you add these two, then you'll get the entire set union, right? Since 1, 2, 3, 4, 5, there are only 5 elements, so 1, 2, 3, 4, 5, no, that's not possible. Okay, 1, 2, 3, 4, 5 and 3, 4, yeah, it is possible, but the size is only 3. And a good one will be 1, 2, 3, 4. So in this, if you take union of these two, you'll get 1, 2, 3, 4, which is size of 4. Maximum possible, right? If you get 4 at this point, good, you got 4. You can't go any further than this. Since if you go 5, that's not allowed. Since 5 elements is the union of all these. So 4 is our answer. Now, how do we get to this conclusion? This example is easy. What if they give you a big set? Lots of sets and each set is there. Even though they have mentioned each and every value, each and every constraint does not exceed 50. I think only the test cases exceed 100. It's at 50. So the thing is, technically you can use a lot of loops. Okay. Since 50 into, even if you multiply 55 times or something, I think it will get only 3 into 10 power 8. Approximately somewhere around that range. And the time is 2 seconds. So they given you plenty of time. Like, chalo, kar lo, jo karna hai. But question solve karo. So, how do we approach this thing? See, the thing is, you need to eliminate one element, right? Most favorable outcome is if you just, from the union set, you remove one element, and whatever answer you get will be the answer, right? That is the most favorable element. If you have a set, the union of all of these, and you remove one element, then you have the maximum set, right? Which is still not equals to union of all of these. Let's go off with that assumption. Okay, let's take 1. Out of 1, 2, 3, 4, 5, let's take 1. If we remove 1, we'll get 2, 3, 4, 5. Good, nice. We'll have 4 elements. The length is 4. Let's see is that possible or not. In this case, we need to eliminate any set that has 1. So this has 1, right? We can't take that thing. We'll go to the next set. We'll see, okay, 4, 5, good. 2 elements, 4 and 5. We'll go to the next one, which is 3 and 4. Oh, 3 is another inclusion. 4 is already there, so 3. 3 elements. Good, we got 3 elements. We didn't know that it was 4. The length can be 4 maximum. For now, we took, okay, if we remove 1 from these, we'll only get 4 elements. Let's write that down. 4. Right. You write it like this. Sorry for the inconvenience. This is a bit weird, but that is how I could write it. 4 for 1. Right. For 2, let's take it. Okay, 2 also we can't do this, the same thing. 4. For 3, also the same thing. 4, you'll get 4 elements. No, Ashish, you won't get that. You know why? Because 3 is also here. So you can't do both of these. So 2 will be the answer. Okay. So 4, in this case, also remove this and you get 3. Wait a second. Ashish, you can write 4 here. It's 3 now. What is the answer? Dumbass. Okay. 4 is here. Okay. 5. For 5, we'll take, okay, 1, 2, 3. These 3 elements are there. And 5 will ignore this thing. And 4. So we'll have 4 elements here. Basically, this is our answer. If we removed 5, we don't need all of that. We only need 4. The answer, the maximum possible set union set length is 4 for our particular union of a particular set that we're going to use. How do we write this in code? See, I'll just freestyle this thing. I'm not going to write it down because it's simple. First, what you'll do is take the count of all the values from the set. I mean, what are the unique elements if you combine them? The unison set which you'll get, what are those? In this case, it is 1, 2, 3, 4, 5, right? Okay, now we have that. Start with each and every, you can take a set and you can take a map, anything your wish. They start with one element, okay, 1. What will happen if I remove 1? It will be good, right? If you remove 1, you'll get 1, 2, 3, 4, which is 4. Think of it that way. It's not, even though it's 3, think of it that way. And go off with the assumption. Okay, 4. Now, we have 4 elements. So we should not take any set that has 1 in it. You iterate through each and every set. And if it has 1, forget about it. Go to the next one. If it does not have 1, then what you'll do is, okay, you'll add 4 and 5. What you can do better is take a variable count. And you can count the values. Okay, 4, 5 from the distinct values that you get. Okay. And since count will be a bit confusing if you have this, in this case, this will be count 2 and this will again increase to count 4, even though there are only 3 elements. So that is set is better. Okay. If you don't want to do complicated stuff, take a set, new set, refresh it every time you go through each and every one of these. For 1, it's a completely new set. This won't even be, don't even touch that. 4 and 5, 2. 3 and 4, 1. So 3. At the end, what you'll do is after you iterate through each and every one of these, okay, you'll check the length 3. And the initial length, we will keep it as 0. Okay, 0. Since I'll tell you why. Since at the end, if all the elements are equal and there is no way you can even add any set to your thing without getting, for example, it's 1 to 3, 1 to 3. How will you add it? 1 to 3 is the elements, and 1 to 3, 1 to 3 is the set. Both the individual sets and the unison all will give it the same thing. In that case, it will be 0. It should be 0. That's why 0 will be the answer. So initially keep it as 0. So you will compare answer, the value, as maximum value of the length of the set you have, the current, the set that you had after checking all of these, and the answer. So whatever that is, in this case it's 3. Again, you'll start, refresh the set, and you'll go to the next element of the set or the map. You'll check the same thing. you get this. Check the same thing. Check the same thing. And in this case, this won't even happen because since it is 3 is greater than 2, so 2 won't be updated in the map in the answer value at all. This it's same thing 3, and in this one we'll get 4. So 4 is the answer now. 4 will be updated. At the end, whatever is the maximum will survive. The survival of the fittest, so fittest one will survive. 4 will survive no matter what will happen. So you'll get your maximum value and then print it. That's it. So the thing is, if you reach this conclusion, it's good, but it's alright if you didn't get this thing, because sometimes it's about how you think, how you approach the question. It's like a maze. Okay, it's like, what do you say, that kind of a maze door, right? I forgot, a room where you have to go through this thing. What is that? Whatever it is, maze. Yeah, I think it's a maze. In that maze, you have to go through each and every solution, possibilities, right? If you have 2 ways, you know that thing looking down like this, but if you're standing there, right there, then you don't know which way to go. Sometimes it's best to just try one out. Maybe you'll get it, maybe you won't. But that's how you get used to it. You look at patterns as you keep progressing throughout your questions, and you try out different things. You try this thing on your question on your own. What you'll get is, you understand patterns. So similarly, even if you're in a maze, even though you're here, understand a pattern after you've been through like 100 mazes. Okay, this most likely won't give us. This is the way. So that's how this thing works. Just practice. Okay, that's the only thing. This is the question. The code is in the description. Thank you.